Hello folks, and welcome back to my YouTube channel. And during this video I'm going to explain to you how to take the basal position using two bearings. First of all, we have to know what is the meaning of bearing. So the bearing is the direction from one place to another, measured in degrees of angle with respect to an accepted reference line. In this case, the reference line is the north.
Well, my friends, first, for taking a true position of a vessel or assumed position, we can use the maneuvering board, the charts, the nautical charts, as this. We can use a plotting sheet too. But in this case, I'm going to use the maneuvering board, and each sheet is going to help me to take the basal position, or to explain to you how to take the basal position. Okay, first we have to know the theory of this method to know our position. So first, the step by step 4-5 degrees to 90 degrees. This is a method to know our position with two bearing. In this case, we have got 4 steps. The first one is we have to take a bearing. With an angle of 45 degrees respecting of the true course, and take note of the time. For example, if we are here and we take at 8:00 local time, you have got to take a bearing respecting this object, target, etc. at point in line, a buoy, I don't know, an static object, for be more exactly. So this angle is 45 degrees respecting to the true course. And we have two part in this case.
If we see the target at port side, we have got to subtract 45 degrees from heading. On the other hand, if we see the target at starboard side, we have got to add 45 degrees to the course. In the first case, if we have got a 330 degrees true, we have to subtract 45 degrees
to 285 degrees, and this angle is that we have to see at the gyro compass. In the other hand, if we see the target at starboard side, we have to add 45 degrees to the course respecting. If we have got 330 degrees true plus 45 degrees equal to 375 degrees, but this angle is more large than 30 degrees, so this minus 360 degrees is equal to 15 degrees. This is the true angle. So the second step, we take a second bearing, this line. In this case, this is the first bearing. Okay, then we have to take a second bearing, in this case with an angle of 90 degrees respecting to the true course. Second bearing, 90 degrees respecting this. As the first bearing, if we see the target at port side, we have got to subtract 90 degrees from hitting. On the other hand, if we see the target at starboard side, we have got to add 90 degrees to the course. As for example, if we have got 90 degrees and we see the target at starboard, we have to add 9 degrees, and this is 180 degrees. Sorry, this is that we have to see at the gyro compass, and if we have the target at the port side, we have to subtract 90 degrees, and this is 000 degrees. This is that we have to see at the gyro compass, and we have to take the time in this at this point, and 0900 local time. Okay, and the third step, with the time set between the two positions, in this case position 1, position 2, with the vessel speed, we can calculate the distance in nautical mile using the formula. Distance equal to speed of the vessel powered by the time sailed. This is the formula that we're going to use. We have got to suppose the vessel have 12 knots. This is the speed of a vessel, and the time travel or the time sailed is the time arrive, the ETA, subtract the ETD, in this case 8 hours. In this case the time travel or the time sailed is 1 hour. Well, then using this and this, we can calculate the distance, and the distance is gonna be the speed 20 knots over by the time 1 hour, and the distance was 12 nautical miles. This distance must be drawn from the target interception to the bearing 2 line. This is gonna be our azimuth position. We take 12 nautical miles. Suppose it's gonna be here with the compass. We here mark 12 nautical miles, and this is gonna be our azimuth position. Using the maneuvering board for know what is the position of a vessel and a determinate time of passing the heading. So first that we have to make at the maneuvering board is the heading of a vessel. In this case, the heading of a vessel is 090 degrees through. So we plotting in this case. Then we take a bearing about an angle to port side of the 45 degrees. In this case, we take the 45 degrees and we have to take note of the time, and in this case was 0000 local time. Then we have to take position with an angle of 90 degrees respecting to the target at the land. In this case we make an angle of 0.9 degrees respecting to the heading, and translate to it to the target position, and it is this one. Then we have to make this angle. In this case 90 degrees, 45 degrees. This time, this is my position 2, and this time was 0120 local time. The time travel was the 1.220 hours. Distance equal to speed of a vessel powered by the time sailing. In this case, the distance going to be 12 knots. This is the speed of a vessel, 12 knots, powered by the 1.10003 hours. And as this distance is 0.04 nautical miles. We have to plot in this distance, or draw this distance, 12.04 nautical miles. We have to draw from the intersection of the two lines, the lines of point 1 and the point 2. In the scale, we are going to use the scale 3 to 1, and we make 12 nautical miles, more or less, is around 3.12, and we take position, send the target to position this, and it's gonna be 3.12, more or less. And this is my basal position, my assumed position.